Welcome back, Math 30-2. Today we're looking at simplifying rational expressions even more. So to start off here, we want to find the non-permissible value and simplify into simplest form. So let's just take out the factors and so on, but the first thing we must always do is find the non-permissible value. That's step one. Always state the non-permissible value first, okay? Because there could be a restriction. So if I look at this, I can't have x as 0, right? So x cannot equal to 0. But when I cancel these off, I end up getting 12x over 2, which is the same as 6x, okay? But now, this graph will look like 6x, except when we graph it, there will be a little place right there where there's a little hole. There will be a little gap. If you put 6 on this, punch in 6, there will be nothing there. It's a little gap, okay? Because that is what x cannot equal because of the bottom. So we have a restriction. That's why always make sure first you put your non-permissible value instead of your before you simplify. Okay? So let's take a look at the next one. Well, what are my non-permissible values? A cannot equal to -1 and -7 from what last class we learned. Now, let's see what cancels off. This cancels off with that, so we're left with a subtract 6 all over a plus 7. But those are my non-permissible values. Okay? Let's take a look at the second one. We have 8y. So y cannot equal to 0. Now I look at this here. Can y divide both of these? No, it only divides one of them. Therefore, I can't divide by y. But a number divides both of those, 2. So we could have with, if I take out a 2, we have 4y plus 1 all over 4y. Both of those can be divided by 2. Okay? Let's take a look at the next one. We have an x squared here, but this is a square number, that's a square number. So that means it's a difference of squares. So I'm going to rewrite this out. We have x plus 7 all over x, or 47. 7 minus x, square root. Both of these, square root, and 7 plus x. Okay? So now I know x cannot equal to 7 or -7. Okay? There we go. Now let's take a look at this here. Also doing this, we could have just gone x squared cannot equal to 49. And we know if we square root this, square root, we could have x cannot equal to plus or minus 7. Because if I go -7 times -7, that's just 49 as well. Alright? Now let's take a look at this. What can be canceled off? X plus 7, I rearrange that. That's x plus 7. So I'm left with 1 over 7 subtract x. Okay? Let's take a look at this next one. Well, what can be factored out of both of these? We have to first see. We're going to see what can be factored out of both of those. I look at this. I could take out here from both of these 4p. And I'll be left with 3p minus, and here we will end up having -2. Okay? All over the bottom, I could take out 2p squared. And what will that give me? 3p minus 2. Okay? So I look at this on the bottom, it's factored. Now that's factored, it's easier to find my non-permissible values. What are my non-permissible values? P cannot equal to 0. And if I solve for this, I'm going to get, move that over, 2 divided by 3. 2/3. Okay? So now I could cancel off some things, and this cancels off with that. So I'm left with 2 on top, and we have that, 2 over p, if we cancel everything off. And that's just my solution. Alright? So let's take a look at this next one. Maybe we need to factor the top. It looks like it's a difference of squares, but first let's take out 3. So it's the same as 3t squared minus 25. All I did was I divided both of those by 3, all over t plus 3, t minus 3. Oh, minus 5. Now I continue this. This can be broken down. These are both squares, so that's a difference of squares. So I'm just going to write over here. So we have 3. I'm going to get t minus 5, t plus 5, all over t plus 3, t minus 5. Now what cancels off? This and this cancel off. And so I'm left with, oh, before we do that, I should do my non-permissible values. T cannot equal to, I have negative 3, and t cannot equal to 5. And we cancel this off, so I have 3, t minus 5, all over t plus 3. Okay, that's that. Alright, so now it wants to go using a common factor of negative 1. So these are the tricky ones. These here might actually cancel out, but it's hard to tell how they cancel out. So that's why we're going to use this common factor of negative 1. So if I take this here, I'm going to take out a negative 1 from the bottom. So if I multiply everything by negative 1, I'm going to get c minus 4, and I'm going to take out a common factor of negative 1 here. So negative 1 times 4 is negative 4. Negative 1 times c is plus c. This could be rearranged to c minus 4 all over negative 1 c minus 4. And these c minus 4's cancel off, so my answer is just 1 over negative 1, which is equal to 1. Okay, see how that works? Now we're going to try one more here. So notice the signs were switched. If the signs are switched, knowing that means we can multiply by negative 1. Okay, so let's take a look at this here. Well, how do I solve for this one? Well, same idea. We first must factor something out. Simplify it first. Okay? Oh, stating the restrictions. Forgot to state the restrictions. C cannot equal to 4. Okay? So let's take a look at this here. I want to take a look at the restrictions. So I have 0 cannot equal to 16 minus 8p. So 8p cannot equal to 16. P cannot equal to 2. So we found that one. That's good. Okay, so that's my restriction. Now, we want to solve this. So let's factor out what can be divided both. I have 2p squared. And so I'm going to have p subtract 2. Okay, all over. What can we take out of here? I could take out an 8. So that's 8 all over 2 subtract p. Now once again, if we look at this, my signs are switched. This is positive, this is negative. Positive, negative. They should be swapped around. So what can I do? I could take out a negative out of one of these, either the top or the bottom. It doesn't really matter. So I'm going to take out a negative out of the top one this time. So it's going to be negative 2p squared, because I have a negative 1 I took out. So negative 1 times p is negative p, and negative 2, that switches around, so I have 2 minus p. These cancel off. This cancels with that. So this is just a 4 on the bottom. So I end up getting negative p squared divided by 4 is my simplified term. Okay? So there we go. Our last example says, the area in meter squares of a rectangular plot can be represented by the following expression. Okay? The length in meters of the plot can be represented by this. Now, write and simplify a rational expression that represents the width of the plot. So, area is equal to length times width, right? So width is equal to area divided by length. So in this case, what is my area? My area is x plus 6 squared. And what is my length? My length is x squared minus 36. Okay? So let's continue this. Now this expanded is x plus 6 multiplied by x plus 6. And the bottom, we actually have a difference of squares here. So that's all over x minus 6, because the square root of 36 is 6, and the square root of x squared is x, and x plus 6. So what can my x not equal? By looking at this, x cannot equal to 0, or sorry, x cannot equal to negative 6, and 6, right? X cannot equal to negative 6 and 6. Because of that, no negative 6 and no 6. And we look at this cancels off. So my length is actually equal to x plus 6 divided by x minus 6. And we know that x cannot equal to those. Okay? Now the next one, it says, the length of the plot is 28 meters. Determine the value of x if x is greater than 0. So the length of the plot is 28 meters. Okay? So the length is 28. So the length is 28. So we know 28 is equal to x squared minus 36. Okay? So determine the value of x if x is greater than 0. So now we have to put that over there. So I'm going to have to add 36 to both sides. So I'm going to end up getting 64 is equal to x squared. Okay, now I continue this, I square root both sides, and it says x has to be positive, it's greater than 0. So then x is either equal to plus or minus 8. Well, it says it must be greater than 0, so then x is equal to 8. Because it can't be the negative, because it says it must be greater than 0. Makes sense. How could the plot be smaller? Okay? Now, the plot has to be treated with fertilizer of a cost of per square meter. Calculate the cost of the treatment. So now we have to figure out how many square meters there are. So x is 8. So I could use this here, my area formula, right there, to find out how many square meters there are. So I use this area formula, that what area is equal to? Area is equal to x plus 36, or x plus 6 squared. Sorry. And we know x is equal to 8 from before. Okay, which is 14 squared. Which is equal to 296. Alright? Now, it says we want 240 per square kilometer, or per square meter, so we just multiply this here by 2.4, which will end up giving me this is 196. 470.4. Okay? And that is $470.4. Okay? So hopefully you understood this. Just made that one mistake. Hopefully you understood this, and good luck as I see you tomorrow as we practice these questions together.